Topics in probability. In this segment, we'll talk about Bayes formula and principles of counting. Bayes formula. Bayes formula allows us to adjust our viewpoint when we receive new information. Before I explain this formula, I will give you an example. Let's say that you are following a given company and you are particularly interested in the earnings per share announcement that this company will make after 2 days. So at the end of 2 days, the company will make an announcement about the earnings per share related to the last quarter. And the company is also going to make an announcement at the end of the day related to whether or not it will expand its operations. Let us say that the event that concerns you, or the event that you are interested in, is the event where earnings per share exceed expectations. Analysts have a certain expectation related to the earnings per share. Let's say analysts expect earnings per share of $2 per share, and you are thinking that the probability that earnings per share will exceed expectations is 0.5. This is our event. Earnings per share exceeding expectation is what we are calling our event, denoted by E in the formula. And the probability of this particular event, i.e. earnings per share exceeding expectation, let's say equals 0.5. At the end of the day, you will get new information about whether or not the company is expanding, and this information is denoted by the symbol I in this formula. As we have already said, the probability of the event being earnings per share exceeding expectation, is equal to 0.5 in our example. The question is, once you get new information about whether or not the company will expand, should you update your probability of this event? And the answer clearly is yes. If the company announces that it is expanding, then that is a good sign, and chances are that the company has indeed exceeded expectations, or earnings per share have or will exceed expectations. Notice that the earnings per share number is known to management earlier. What is only happening here is the announcement. You as an analyst don't know what the earnings per share will be, but you are using information such as company announcements to come up with a probability of whether the earnings per share will exceed expectation or not. So in simple terms, here is what Bayes formula is doing. It is starting with a certain original probability of the event that you are interested in, and then that probability is being updated based on the new information that you receive. And the way the formula works is this. The probability of the event given the new information is equal to the original probability of the event times probability of information given event divided by the probability of the information. Many students have trouble over here with the conditional probabilities, but once we work through the numbers here, it will become easier, and then you have to find problems on Bayes formula and practice them to really understand this concept well. So as we said, the original probability of the event being earnings per share exceeding expectation, equals 0.5. While we are at it, let us also see the probabilities of the other possible events. The probability that earnings per share meet expectation is 0.3, and probability that earnings per share are below expectation is 0.2. These are prior probabilities prior to receiving any new information. Also notice that these three probabilities are mutually exclusive and exhaustive. Let us also look at some conditional probabilities. The probability that the company expands given that EPS exceed expectations is 0.75. The way you can think of this is as follows. The company management, which is ultimately announcing the EPS over here, already knows the EPS number. This EPS number has not been announced, but you as an intelligent analyst know that the company is more likely to expand if the EPS number is good. So you come up with these conditional probabilities, and these are subjective probabilities where you estimate that the probability that the company will give this information or company will expand given that EPS exceed expectation is 0.75. The probability that the company expands given that EPS equals analyst expectations or EPS meets expectations is 0.2, and the probability that company expands given that EPS are below expectations is 0.05. It should be fairly logical that this number is small, because clearly if the EPS is low or weak, then probability that the company will be expanding is low. So these are your conditional probabilities. Now let's say you get to the end of the day and the company makes an announcement. The new information or the announcement is that the company will indeed expand. Here is where we use Bayes formula, because now with the new information we need to update this probability. So given that new information, we now say that the probability of the event being earnings per share exceeding expectation, given the new information is what? So we need the original probability of the event, which we have 0.5. We need the probability of the information given the event, which we have over here. Remember, the information is that the company expands, and we had this number over here. The probability that the company expands given that EPS exceed expectations, that is the event E, is equal to 0.75. So we know this number is 0.5. We know this number is 0.75. The question is, what is the probability of the information? And notice, this is a unconditional probability. To compute the unconditional probability, given several conditional probabilities, we need the total probability rule. So let us use it. The probability of the information, which is the first thing we need to find over here, is equal to the following. It is the probability of information given the event being EPS exceeds expectations, times the probability that EPS will exceed expectations, plus the probability of the information, i.e. company expands, given that EPS meet expectations, times the probability that the company will meet expectations. So we'll express that event as M, and then plus the probability of I given B, where B is a situation where EPS is below expectation, times the probability that EPS is below expectation. We have all these probabilities. Probability of I given E is 0.75. Probability of E is 0.5. Probability of I given M is 0.2, and the probability of M is 0.3. The probability of I given B is 0.05 times probability of B is 0.2. You add up all these numbers, and what you should get is 0.445. So the probability of I being the information, so information, the probability that company expands is 0.445. So this is the unconditional probability that the company expands, and this is the probability that you are actually computing before the information was released. 0.445, that is what you plug over here. So instead of PI, you can now put in 0.445, and when you do the maths, 0.5 into 0.75 divided by 0.445, what you should get is 0.84. So the interpretation is that the probability of the event being earnings per share exceeding expectation, given the new information that the company expands, is 0.84. And this makes sense. Our original probability was 0.5. This has gone up to 0.84, which makes sense because when you have this new information that the company expands, then obviously there is a greater chance that EPS will exceed expectations. Now we will talk about principles of counting, which are much simpler than Bayes' formula, and we will essentially talk about the multiplication rule, the factorial, labeling, combinations, and permutations. Let's first talk about the multiplication rule. Let's say that you have a process that consists of 3 different tasks: task 1, task 2, and task 3. Let us say that the first task can be done in 4 different ways. And then once you've done the first task, the second task can be done in 2 ways. And once you've done the second task, the third task can also be done in 2 different ways. So the question is, what are the total number of ways in which these 3 tasks can be done? And the answer is arrived at using the multiplication rule. So the number of ways in which the k tasks, k is equal to 3 in this simplistic example. So the number of ways in which 3 tasks can be done is equal to the number of ways in which the first task can be done, which is 4, times the number of ways in which the second task can be done, given that the first task is already done, that is 2, and the number of ways in which the third task can be done, given that the second task is done, that is 2 over here. So the answer to this question, the number of ways in which these 3 tasks can be done, is 4 times 2 times 2, that's 8 into 2, which is 16. A common application of the multiplication rule is the factorial, and you will see this very often. When we say n factorial, what we mean is the following: n into n minus 1 into n minus 2. And let us take a simple situation to understand the use of this formula. Let's say that you are in charge of a research department, and this research department is evaluating 4 different industries. And you also have 4 research analysts working for you. You need to assign these 4 research analysts to 1 industry each. In how many ways can you assign the first research analyst? The answer is you can assign him to one of 4 industries, so you can assign him in 4 possible ways. Once the first analyst is assigned, the second analyst can be assigned to one of 3 possible industries. So you can do that 3 different ways. Then we can assign the next analyst in 2 different ways, and then the final analyst will be assigned to the 1 remaining industry. So notice that with 4 different analysts, the total ways in which they can be assigned to industries is 4 times 3 times 2 times 1. This is also called 4 factorial for short. So 4 factorial is equal to 4 into 3 into 2 into 1. And what you see here is the general case scenario where we say that n factorial is equal to n into n minus 1 into n minus 2 and so on until we come down to 1. And just to hammer this in, 4 factorial would be 4 into 3, which is 12. 12 times 2 is 24. Once you've understood the concept, you can simply use the factorial button on the calculator, which is right here. So to calculate 4 factorial on your calculator, you simply type in 4 second and then this factorial over here. Next, we talk about labeling. Say you have n items of which each can receive 1 of k labels. The number of items that receive label 1 is n1. The number that receive label 2 is n2, and so on. To understand this, let us look at a simple example and then we'll see how to use this formula related to the number of ways in which labels can be assigned. A portfolio consists of 8 stocks, which means that n is equal to 8. So you have n items, here we have n stocks, so n is 8. The goal is to designate 4 of the stocks as long-term holds, designate 3 as short-term holds, and designate 1 stock as a sell. Now notice each of these is a label. So long-term holds is a label, short-term holds is a label, sell is a label. So k is equal to 3 because k is the number of labels. The question is, in how many ways can these labels be assigned to the 8 stocks? And that is where this formula comes in. The number of ways in which the labels can be assigned is equal to n factorial. So in our example, that would be 8 factorial because n is 8 over here, divided by n1 factorial. This means that for our very first label, which is long-term holds, the number that need to be in this or under this label is 4. So n1 is equal to 4, and that is this item over here. So divided by 4 factorial multiplied by n2 factorial. The second label is short-term holds, and we need to designate 3 stocks under this label. That is the n2 factorial. So we say multiplied by 3 factorial. And then the third label is sell. Only 1 stock needs to be under this label, so we multiply by 1 factorial. Now if you solve this on the calculator, you can simply type in 8 factorial divided by 4 factorial times 3 factorial. 1 factorial is simply going to be 1. If you do this, what you should get is 280. So that is the number of ways in which you can assign labels to 8 stocks. Permutations. Permutations refers to the number of ways to choose R objects from a total of n objects where the order in which the R objects are chosen does matter. Here is the formula for NPR. N factorial, that's the total number of objects, divided by n minus R factorial. Let's look at a simple example. Say you have a portfolio of 8 stocks, so n is equal to 8. We decide to sell 3 stocks. How many ways can we choose 3 of the 8 stocks to sell if the order of the sale does matter? This means that we use the permutations formula. R is equal to 3. So the formula is n factorial, which is 8 factorial divided by 8 minus 3 factorial. So that is 8 factorial over 5 factorial. You can do this on the calculator and you should get 336. Next, let's talk about combinations. The number of ways to choose R objects from a total of n objects when the order in which R objects are chosen does not matter. And here is the formula for NCR. Again, let's look at an example. A portfolio manager wants to eliminate 4 stocks from a portfolio that consists of 6 stocks. So n is equal to 6 and R is equal to 4. How many ways can the 4 stocks be sold when the order of the sale is not important? So the order is not important. That means we need to use the combinations formula. If you plug in over here, you have n factorial, which is 6 factorial, divided by n minus r, that is 6 minus 4 factorial, multiplied by r factorial. R is equal to 4, so multiplied by 4 factorial. When you do the maths, you get 15. And again, notice that you can do NCR directly on the calculator. So just type in 6, second, NCR 4, and that should also give you 15. So that is it in terms of this particular reading. I will quickly summarize the most important points. We started by talking about probability. You need to understand the concept of mutually exclusive and exhaustive events. You need to understand the concept of conditional probability, where we essentially talk about a probability conditional on another event. We then talked about the multiplication rule. So the probability of A and B, the joint probability, is equal to probability of A conditional on B times the probability of B. We also need to understand the addition rule, which is probability of A or B, which is probability of A happening or B happening or both happening, is equal to probability of A plus probability of B minus probability of AB. So that is the joint probability of A and B. You also need to understand the total probability rule, which essentially is a way of moving from a conditional probability into a unconditional probability. So the unconditional probability of A is equal to the probability of A given a particular scenario times the probability of that scenario plus the probability of A given not that scenario times the probability of not that scenario. Not that scenario is often denoted as S complement. This is a simplified two-scenario version of the total probability rule. This particular rule can be expanded into multiple scenarios as long as all the scenarios are mutually exclusive and exhaustive. We then talked about the expected value of a given random variable, which is fairly straightforward. We simply take the different values of the random variable and multiply by the probabilities for each of those random variables. So if a random variable can simply take on two values, x1 and x2, then the expected value would be the probability of x1 times x1 plus the probability of x2 times x2. Variance then gives us a sense for how spread out the random variable might be relative to the expected value. That formula is a little bit complicated, so if you need to revise it, you can go back to the notes, plus you need to know how to calculate variance using the calculator. Covariance is a measure of how two variables move together. Covariance being positive means that variables generally move up and down together. Covariance negative means that if one variable is going up, the other is likely to be going down. Then we talked about expected value and variance of a portfolio. The expected value was fairly straightforward. Variance of a portfolio involves knowing the covariance between the different elements of the portfolio, the weightage of each element, the standard deviation of returns, and so on. And then finally we talked about counting, which involved permutations, combinations, and labeling. This is fairly straightforward. So that is it. What you need to do now is review the learning objectives, do the examples and practice problems from the curriculum, but recognize that the questions are fairly difficult. So if you have trouble, don't worry too much. Just try to understand the solutions. It is extremely important that you practice as many questions as possible from other sources. So Schwezer has a lot of good questions, plus you might get questions from FinQuiz and so on. You can also solve the questions that have been released by IFT. When you do a lot of questions, then you will be comfortable with this topic.